Welcome back, Cat 31 CATIA class. Today we're going to go over the dual clevis, problem 4-2. Alright, so let's go ahead and focus on this front view. So we'll call this the front view. And on top we have the top view, which has been turned into a section view AA. So section view cuts down usually down the middle to expose the inside of a part, to expose some of the features, in this case the counterbore holes. Alright, so we're going to take the front view, create a sketch. Now this radius here, we can find it in the section view, the top view. So it's 4.125. And we're going to go ahead and just create a very simple sketch and leave out some of the details. Then we'll do a pad and then take care of the features such as the slots, counterbore holes, and some of the other fillets or radii or round corners. Alright, so let's start with the sketch front view with the radius of 125. Alright, so let's go ahead and go to the correct workbench. Start, mechanical design, part design. And this will be problem 4-2. And OK. Alright, so let's go ahead and maximize. Maximize again. Take advantage of the entire screen. Okay, so I'm going to sketch on the YZ plane. So I'll pre-select it. Click on sketch. Now one thing I forgot to do was to check my units. So let's check our units. Let's go to Tools Options. Go to General, Parameters and Measure, Units, and this drawing is in inches. Okay, so make sure you are in inches. Okay, so we're going to create a radius of 125. Okay, notice there's 4x. The 4x tells us that there are 4 round corners or semicircles of a radius 125. There are 4 of them. 1, 2, 3, 4. Okay, and they have a radius of 125. Okay, so we're going to create an arc. So if you go to the circle command, let me move this out of the way. Go to the circle command, go to the drop down. We're going to create an arc. Click on it. And if you're not sure what to do first, we can always read here at the bottom left corner of CATIA. It's asking you for a center. Okay, so let's go ahead and create a center. And I'm going to go vertical. So my quadrant point, I want it to line up with the vertical. So I'll click here and start rotating till I get to this top quadrant with respect to the vertical, and click. Okay, so there's my arc. Okay, pretty straightforward. It's centered about the origin. Okay, so let me click in space to deselect. And I'm going to go ahead and draw the rest of it. So I'm going to use the profile command, profile. And I currently have object snap turned on. Let me turn it off. I'm going to go ahead and turn that off. Okay, so object snap, it'll snap to the grid in the background. I prefer it off. Some of you will prefer it on. It's a matter of preference. Okay, so notice how I see that filled blue circle letting me know I'm picking a net point, or it can be a midpoint also. Click. I'm going to ignore the slot that's in this area. All right, so I can now exit. All right, so let me click in space to deselect. Notice it did create a horizontal constraint, a vertical, but it didn't create the one up here. So let me go ahead and add a horizontal constraint. Maybe for you it did create it. For me it did not. So let me go ahead and apply a horizontal constraint. Okay, there it is. Okay, so now we're going to add a radius. Oh, one thing I'm missing also. I'm missing a tangency. Notice how I do have a tangency here. So this line is tangent to the arc. This one is not. So this one, oh, there it is. Actually, it did create it. If it didn't create it, I can always hold on to the control key, select the arc, select the line, and then I can add a tangency constraint, which it already has, right? We want tangency. And what's the difference with having tangency and not having tangency? Then let me show you here on the side. Don't do this part. Just to show you the difference between tangent and non-tangent. Okay, so this is not tangent, right? This is tangent. All right, so let me go ahead and hit undo a few times. There it is. Just had to do it once. All right, so now we have a radius of 125. So let's go ahead and add that radius of 125. Okay, there it is. And we need a length here. So let's go ahead and take a look at the drawing and get that length. All right, so we have to do a little bit of math. So the length from center to center is 375. Okay, so from center to center, 375. And then we have to add 125. So that's the radius, 125, that we see over here on the right. Okay, so the length from the center all the way to the edge is 375 plus 125. Okay, so let's go ahead and add a dimensional constraint from the vertical to the horizontal. Okay, there it is. Double click. So I'm going to let CATIA do the math for me. I'm going to type in 3.75 plus 1.25. The 125 is the radius. Okay. Hit OK, and it gives me 5. So it does the math for me. Click in space to deselect. And there's our first sketch. We're going to ignore the slot. Later on, we'll come back and do the slot. Okay, so let's go ahead and exit. But before I do, I forgot to do a tool sketch analysis. And everything's closed. Everything looks good. If it's not closed, you have to go in there and fix it. All right, so let's go ahead and exit the sketch. All right, so notice how when I created my sketch, let me click in space to deselect, the arc is centered about the origin. That way I can take advantage of symmetry if I need to. Okay, so let's go ahead and now the depth. So what is the depth? Well, it's just 125 plus 125. It's the radius times 2. Okay, so the depth from center to any point on the arc is 125. Center to any point on the arc is 125. So the total depth is just 125 times 2, which is 2.5. Okay, so 125 is our times 2 is our depth, which is 2.5. All right, so let's go ahead and do a pad. Let me go ahead and open up the tree so you can see what happens to the sketch. So I'm going to create a pad, same as extrude. of sketch 1, and when I select sketch 1, it's going to tuck it underneath pad 1. There it is. So I'm going to type in 125. Instead of 250, I'm going to type in 1.25 for the pad thickness, 1.25. Get a preview. Okay, so I have a preview at 125. Now I'm trying to stay symmetrical. I could have typed in 250, but I wanted to stay symmetrical about the X, Y, Y, Z, and ZX planes. So I'm trying to stay as symmetrical as possible, because later on I can use that to my advantage when I'm creating symmetrical features. All right, so 125 in one direction, and then I can say, hey, I want to mirror the same dimension to the opposite side. So it's also going to go 125 to the opposite side. When I click this mirror extent in 3, 2, 1, selected. So it also went 125 in the opposite direction. So 125 plus 125 will give us the 2.50. And okay. Actually, it said preview. There you go. You can see that it's symmetrical. Now, if you wanted instead of make it mirrored symmetrical, you have more options. You can click more. So notice in the opposite direction, that's called the second limit. It went 125. It's the mirror of 125. But if you didn't want to mirror it at 125, you could have always turn off mirror, and you can give it a separate thickness, as you can see. If you wanted to, give it a separate thickness. But in our case, we want to keep it symmetrical. So we're going to say, hey, you know what? Let's go back to mirrored. Notice it grays it out because it's mirrored. It's great. You can't change it because it's linked to the first one, to the first limit of 125. All right, hit OK. Okay, use the wheel to pan. Wheel and right button, hold on both to rotate, and move the mouse to rotate. Okay, so I'm going to show you a different way to round off this portion here. So I'm going to introduce you to the tritangent command. So it's a fillet command to round off using 3 tangencies. Okay, so what we're going to do is we're going to be selecting these 3 surfaces to create our tritangent fillet. Okay, so let's go back. So we're going to create our tritangent fillet. Actually, earlier I mentioned the wrong surfaces. We actually want to pick this surface, the opposite surface, and then the flat surface that we currently have on this side. Okay, so let's go back and create that tritangent. So I meant to say this surface, not the one on top, but we're going to pick this surface, and this surface to create our tritangent fillet. Let me click in space to deselect or hit escape on the keyboard. Okay, so instead of fillet command, instead of the edge fillet command, we're going to use the third option, tritangent. So tritangent fillet, click on it. All right, so first we're going to pick the outside surfaces. So we're going to pick this surface. I'm going to rotate it. Pick this surface. And then we pick the middle one. So the middle one is last. Notice how in the window here, it jumped over to the next row, which is the face we're going to remove, which is this one, the middle one. So I'm going to click on it, and it'll turn a different color. So it's letting us know it's going to remove this surface completely. Let's get a preview. So notice it's going to round it off while staying tangent to the 3 surfaces we chose. And again, the middle one we always pick last. Okay, this is the one that's going to be removed. And 3, 2, 1, don't blink, and okay, and it's rounded. Okay, so that's good. That's what we wanted. All right. Now let's go ahead and add the slots. Okay, so we have these slots in here. I want you to notice that the slot has a radius of 144. Okay, so it's actually, the radius is larger than the 125, obviously. Okay, so the slots have a radius of 144, and it is centered So the 125 and the 144 radii are centered. So they share the same center point. Same thing on the opposite side. We have the exact same situation that we do here on the right. We also have it over here on the left. Radius of 144. Notice the 2x tells us that there's two of them. One here and one here. All right, so let's go back. Okay, so I'm going to create the slot first on this one, the back one or the left one, and then I'll come back and do the right one. So I'm going to take advantage of the symmetry we used. So notice the YZ plane, it's right in the middle, right? It's right in the middle. Okay, so I'm going to select the YZ plane, same plane I used for sketch 1. Okay, so click sketch. Okay, so I want you to notice, you don't have to rotate this. I'm going to rotate to show you that the sketch is going right down the middle. Okay, let me click normal. If you click normal again, it'll flip it 180. Click it again, it'll flip it 180 again, and it'll keep the sketch parallel to the screen. All right, so let me zoom in a little bit. Hit normal. Oh, normal, there it is. All right, so we're going to create a circle right at that center point. Okay, so right at the center point, we're going to create a circle. So we don't want the arc anymore. Notice it defaults to arc now. Let's go to the drop down. Look for the circle. There it is, circle. So now the circle takes its place. Go to the center. So make sure you click the origin right at the center. I can see the filled circle. It may be hard to see that filled circle. I can always darken the background if I want. So if the gray block in the background makes it difficult to see your geometry in your second sketch, you can always turn it off, or low light, I can say. That's what I meant to say. Okay, so now it's easier to see the origin. There it is. You can see the filled circle letting me know I'm picking the origin. Okay, so now I can create my circular sketch, give it a dimensional constraint with the radius of 144. Okay, so I'm going to double click on this. And instead of diameter, I'm going to pick radius. And I'm going to type in 1.44, 1.44. And okay. And as we mentioned earlier, the radius on this slot is larger than the 125 on the solid. All right, so we're actually done with our sketch. We can do sketch analysis. Looks good. Okay, we can now exit. Click in space to deselect. So there's our sketch. And let me go ahead and give this some color. You don't have to do this part. I'm going to right click on the part body, right click properties. Give it some color. Go to the graphic tab panel. The first one is to change the color of the surfaces. I'll go to blue. The second one is to change the color of the edges. I'll just leave it as black. Also, if you have any lines floating in space, especially this is common in surfacing, Cat 37 class, different class, you can give your lines, curves a different color. And also the dots, the points in space, give it a different color. I'll leave those alone. Okay, there it is. All right, so I'm going to take this sketch 2 and I'm going to make a pocket. Okay, let's go back to the drawing. So that pocket. Okay, so we're going to go 0.75. So the thickness that we want to keep on this crevice is 0.75. All right, so we can do some math. We can say 125, excuse me, minus 75. That gives us 0.5 in each direction. All right, so let's go back. We're going to do a pocket. Pick our sketch. All right, so we can say, hey, we're going to go 0.5, so it's just 125. 125 minus 0.75. Preview. And there's our pocket, half of it. Now we're going to mirror it. We're going to mirror it. And OK. And there's our pocket. That's the pocket we wanted. And to check the thickness, we can always use our calipers. Pick the calipers. And you can see this is 0.75. Okay, so once again, let me double click on this pocket. So for our depth, I picked 125. That's the radius. Minus 0.75. So from this center point, from the center to this edge is 125. Minus 0.75 gives us 0.50. Okay, so it's 0.50 plus 0.50. That gives us 1 inch. So this pocket is 1 inch total. Okay, so once again, pocket 0.5 in each direction for a total of 1 inch. And okay, and we can always use a measurement to double check. We can take measurements from this surface to this surface. You can see it's 1 inch. From this surface to this surface should be 0.75, and you can see it is 0.75. And let me cancel out of that. Okay, so now we're going to do the exact same thing on the other side. Exact same thing, except instead of using the YZ plane, we're going to use the XY plane. So we got to use a different plane for our circular sketch. So we're going to repeat the exact same thing we just did with the slot, except we're going to use a different plane. XY, create our sketch. Gives us a different orientation, as you can see. All right, so we want it centered about this arc. Okay, so I'm going to project this arc over. I'm going to project it out towards our sketch. Look for the floating textbook. Project. Okay, I can always pull the toolbar. So we're going to project. If you don't see the project command, you can always go to insert and look for it. There it is, project. But I see it here on my toolbar, so I can just click on it. So I'm going to project that edge. Project it. Okay. And then click in space to deselect. Notice it's yellow. The reason I projected the arc is because I want to use the center of the arc to create my 144 radius circle. All right, so now we're going to create a circle, just like we did in sketch number 2. Okay, so let's create a circle. I'm going to hold on to the wheel to pan a little bit downward. Okay, now I want it centered to this arc. So I am in the circle command. As you can see, it's orange. I want it centered about the arc, so I'm going to right click on the arc. I'm going to right click and say, hey, I want the center. So I want to be concentric. So concentric, meaning our new arc or circle will be centered with this pre-selected arc, right? So it's going to share the same center of the arc. So I'm going to go concentric. Notice it centers it to the arc. They're sharing the same center. Okay, so let's go ahead and click to generate our circle. Give it a radius. Double click on it. Make sure it's radius. And type in 144, 1.44. And OK. And there it is. So we're done. Now let's go to Tool Sketch Analysis. Tools, Sketch Analysis. It's like, hey, something's open, something's wrong. Notice we see the cyan circles. So it's telling us, hey, there's a break here. This yellow arc is not a close profile. Now the circle is a close profile, as we can see, but not the arc. So we can always change it to a construction element. So here's construction. It's the same one we see over here in the toolbar. So we can either delete it, which we don't want to do because we want the center of that arc. We don't want to delete it, but it's not part of the final profile. So we can always convert it to a construction element. So when I click on it, it will turn into dashed lines. Click on it. There it is. Notice it took it off the list. Close. Click and space to deselect. And notice it's dashed. So it's not part of the final profile, but we do need it, right, as a reference geometry in this case to grab its center, to center the circle. Okay, so now we're good. Now we can exit the sketch. Okay, we're going to do the same thing we did earlier. We're going to do a pocket. This time I'm going to do it a little different than the first one. Than the first pocket, I'm going to do it a little different. All right, so once again, it's 0.75 from the outside surface, right? So I'm going to show you a different way using that 0.75. Okay, so I'm going to select the circle. I'm going to do a pocket. Okay, so it's already creating the pocket for me, right? I can do a preview. But I'm going to give it I'm going to dimension it a little different than the first one. I'm going to say, hey, I want to go up to a surface or plane. So plane or surface. I want to go up to this surface here. I want to go up to the surface. I want to go up to this surface. Notice it's already cutting all the way through, and I'm saying preview. Now we don't want to go all the way through the surface. So I'll say I want to go up to the surface, but I want to do an offset of 0.75. So if we go back to our sketch, currently our pocket is cutting all the way through up to the surface, but we're going to do an offset of 0.75 so as to not to remove this part of the clevis, right? So we're going to type in an offset of, so we're going to back it up 0.75. And let me click away. It actually went 0.75 beyond, so I need to put a minus to go back. So to go in reverse, I'm going to click in here and type in a minus 0.75 and preview. Oh, didn't give me what I want. Okay, so let's see. Let me hit OK, see what I get. Okay, so my mistake. Let me double click. Looks like it did an offset from the entire, all the surfaces. The pocket is actually in there, but it did an offset off of all the surfaces. That's not what I wanted. So in this case, it didn't work. What I wanted to create, it didn't work. So instead of up to surface, let me say plane. So I'm trying to get this to work instead of up to surface. So it did an offset of the entire block. I just want this surface. Let's see if I can fix it by picking plane instead. Up to plane. Pick the surface. Okay, so even though this is a surface, it recognizes that it's planar, right? It's flat. So up to plane, good. And we're still going to leave that minus 0.75 preview. And this time it did work. Okay, so this time it only offsets off of this surface. And not like I did previously, which I was not expecting. It did an offset of all the surfaces. With respect to all the surfaces, I only want this surface. Okay, so good. There it is. Now in this case, I cannot use mirror. That's okay. We can go to more and do the exact same thing for the opposite side. We're going to do the exact same steps. We want to go up to a planar surface. So we're going to go up to plane. This side. And we're going to do the minus 0.75 setback or offset. So minus 0.75 inches and preview. And there we have it. So there's another way of creating that pocket. And okay. And there it is. We have our pockets. All right, so we're almost there. All we need are the counterboard holes. So we're almost done here. Okay, so we have counterboard holes, 4 of them. So the 4x, let me zoom in here a little bit. So the 4x tells us that there are 4 holes. This U symbol tells us that there's 2 holes, referred to as counterboard hole. Okay, so the first hole, oh, so it actually labeled it separately. Okay, so this 0.75 should have actually been included here with this one, but that's okay. Just another way of dimensioning. Okay, so the first hole, the little one, has a diameter of 0.75. So you can also see it here. This little hole, the smaller one, has a diameter of 0.75. And then the larger, it's followed by a larger hole that has a diameter of 1.375. And the downward arrow tells us how deep that second larger diameter hole goes. So it's 0.312. Okay, so this larger hole has a depth of 0.312. Okay, so let's go ahead and create that 0.75 diameter hole. Small one, followed by a 1.375 larger diameter hole, depth of 0.3125 or 0.312, my mistake. All right, so let's go ahead and create that counterboard hole. Okay, so one thing you have to do is to center it with this arc or this tritangent fillet is to pre-select the edge. So by pre-selecting the edge before we click on the hole command, notice how it's red, right? If you click the surface, it'll turn orange. We don't want the surface, so let me deselect by clicking out in space. Select the edge, the arc. Notice it's red. Okay, now we can go over to the hole command. Hole command. And pick the surface. So I'm going to pick the surface, but you're going to see it's going to center it about the arc. Even if I pick out here, watch what happens. See, it moves it over, so it's centered with the arc. Okay, so the small hole is 0.75 in diameter. And we can say, hey, we want this hole that we're currently creating to go up to the bottom surface. Okay, so we just wanted to go up to this bottom surface, so we can say, hey, we want it to go up to next. And there it is. See how it stops up to next surface that it encounters as it's driving the hole. You can always say, hey, I want to go up to last. Goes all the way through. You can say up to plane or planar surface. Say I want it to go up to here, right? You can say I want it to go up to a surface. Say I want it to go up to here. Okay, in this case, we can simply just say up to next. There it is. Goes up to the next surface it encounters. Okay, there it is, and hit OK. And there's our 0.75 diameter hole. I can always measure it to double check the measurement. You can see it's given it to us in radius. 0.375 times 2 is 0.75 diameter. Let me cancel out of this. All right, so now we can come back and create a larger hole for the counterboard, which is, once again, 1.375 in diameter with a depth of 3.12. Now, instead of having to use the hole command again, one cool thing about CATIA and other softwares is instead of a simple hole, so currently we have a simple hole, we can say, you know what? Instead of a simple hole, we can turn it into a counterboard hole. So let me double click on hole 1. I can do it here, or I can do it here. Double click on it. And say, hey, instead of a simple hole, let's go over to the type tab, go to type, Notice we currently have a simple hole. We want a counterbore hole, right? So counterbore, and it'll give you a preview here on the right. Counterbore. Okay, so over here we can see on the right, preview, it's going to create the double hole, right? That's what we want, counterbore hole. And our diameter for this second counterbore hole is 1.375 with the depth. So I'm left mouse clicking in here and highlighting. So I hold on to the left button on the mouse to highlight to replace this with 0.312. Okay, and get a preview. Notice there's our counterbore hole. Okay, so we have our counterbore hole. We can always go back to the first tab. If you go back to the first tab, there's the information for the small hole. Diameter of 0.75 for the smaller diameter hole. Go to the type tab. And here's the information for the larger diameter hole with a diameter of 1.375 and a depth. So it has a depth going down to 0.312. And hit OK. So there's our counterbore hole. Okay, so instead of repeating it over here on the bottom, I can do a symmetry if I want to. Or I can just do it 4 times for that counterbore hole, or do it 3 more times so we can have a total of 4 counterbore holes. One option you can do is mirror it. Okay, so I'm going to pre-select the hole. Say, hey, I want to mirror. So here's the mirror command. If you don't see it, most likely it's probably buried down here somewhere and you have to dig it out. If you don't see the mirror command, you can always go to the pull down, insert, go down to, it should be transformation, features, and go to, not symmetry, but mirror, because symmetry will delete the original hole. We want to keep the original one. So let's go to mirror. Okay, so I'm going to mirror. Notice how since I pre-selected the hole, I want you to notice that it's already populated, letting me know, hey, you pre-selected the hole. You can actually pre-select more than one feature. You can hold down to the control key and select a bunch of features that you want to mirror in one shot. In this case, I just want to do hole number 1. Now it's asking me for the mirroring plane. So the plane we're going to mirror about is the YZ plane. Okay, the YZ plane. 3, 2, 1, click. Notice it's already mirroring. We can hit preview. You can see that it's mirroring that counterbore hole. And hit OK. And there we have it. Okay, so now we're going to do the same thing for this flange or this part of the clevis. So it's going to remember the last numbers we used for our first counterbore hole. It'll keep the exact same numbers. Okay, so I'm going to pre-select the edge. Click on hole command. Click on the surface. And because I pre-selected the arc, it centers it to the arc. As you can see, it's centered. And it remembers our last inputs. Okay, if I hit preview, you're going to see it has the exact same inputs as it did earlier. Hit OK, and there it is. We have our counterbore hole. And we can mirror it again like we did the previous hole. Okay, so let's go ahead and go to mirror, insert, transformation, mirror. Now I forgot to pre-select the item, so it thinks I want to mirror the entire solid. I don't. So let me click in here and say no, I don't want to mirror the entire solid. I just want to mirror it. Hole number 2. There it is, hole number 2. Or else it would have mirrored everything. Okay, so notice I have hole number 2. Now let's click here to pick our mirror plane. Okay, so we want to mirror. This time we want to mirror it over here, so we're going to use the XY plane. There it is. And OK. And rotate. And there's our completed part. All right, so just want to make sure that we didn't miss anything. So we completed every single feature on this dual clevis. All right, so let's go ahead and save it. So File, Save As, save it on your desktop, up on the cloud or Dropbox, wherever you want to save your files. I'll save it in my Cat31 Chapter 4 folder. Okay, so this is problem 4-2 and save it. Alright, so that's the end of this YouTube video. See you in the next one.